Hi, I'm Cosmo Ye. You've seen me in such fine quality, epic chemistry educational videos such as Metric Mania and the World, Part 2, and Millimeter, 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 My Kingdom for a Millimeter. Okay, the idea behind this video today is we're going to show you how to measure something in millimeters using the metric system, centimeters, and whatnot. But first, we have to look at, all right, we got a ruler here. So what's the difference? Well, if you look at the top here, this is the inches side here. This is how you know that you have the inches side, because you may notice that the markings, while they are the same distance, okay, from each other, you got 11, 12, 10, 11, 12. Those are inches. Now, the side that we're going to be using is the metric side. Now, if I flip this over like this, okay, let me get that over this way, you will notice that toward the edge, right about here, you may notice it says millimeters and centimeters. So how do exactly I read this? Well, if we look, we have 1, 2, 3, 4, 5, 6. Those numbers there represent the centimeter, okay? And if you were to go and count in between, let's take between 1 and 2 here, and you notice there are smaller units. There's a smaller scale there. So what do those represent? Well, they represent millimeters. So if we go from 1 centimeter to 2 centimeters here, we have 1, 2, 3, 4, 5. Notice on my halfway point here, it's a little bit larger. And then 6, 7, 8, 9, 10. So that means for us, we have the following pieces of information. We know that 10 millimeters is equal to 1 centimeter. Now, considering I'm writing this upside down, I think that's pretty good for what we're doing. Now, remember, this is your inches side. Oops, I'll get this down here. This is your inches side. You're not supposed to use that for the purposes of our density lab. What you're using is this. Okay, so how do we go and measure an object? So let's go ahead, let's take an object like this piece of rubber. Okay, so I'm going to put it over here, and I'm making sure that I line it up at the end there, and let's see, is it? Yeah, there we go. So, okay, so that's lined up. So, how many centimeters do I have? Well, I have 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters. But is it exactly at 5 centimeters? No, and I just moved the ruler a little bit. No, actually, there's 1 extra bar after the 5 centimeter mark. So how do I write that? Well, there's 2 ways I could write that. I could write that in millimeters, where it's 5 centimeters times 10 millimeters to 1 centimeter. That gives me 50 millimeters plus that 1 millimeter. So I could sit there and say, hey, that is in fact 51 millimeters. But that is also equal to how many centimeters? Well, 51 millimeters, there are 10 millimeters for every centimeter, so that means it's going to equal 5.1 centimeters. Okay, so again, we can double check, and we'll see that, okay. So I'll move that up a little bit. Let me move the paper up so we can see that. So we line that up again. And if you notice, yeah, it comes out to about 51 millimeters or 5.1 centimeters. So in the lab, we're going to be working with the metric system. And just a quick thing to let you know, 1 centimeter cubed is equal to 1 milliliter. Okay, we'll just keep it simple. So how do I go and make the measurements for this? Well, in other words, because it is a three-dimensional object, there's a volume to it. Well, volume is length times width times height. Okay? So if the volume, we're going to move the paper over. Okay, if the volume here, let's say the volume is equal to length times the width times the height. That's our basic, oops, there we go. There's our basic formula right there. There's our formula. So how do we measure this? Are we going ahead and using this side here? Nope, that's our inches. We don't use that. But we can use this side, our metric. So we'll go ahead and we'll just measure it another way. Actually, let's just go and do it the way I have been doing it, like this. So I know for the length I have 51 millimeters or 5.1 centimeters. Okay, so I'm going to write that off to the side. There is, let's see, let's bring that up here. So we know that there is 5.1 centimeters multiplied by, okay, well, we're going to take the width and we're going to look at this part here. So again, we'll set it up, and I see it's going to be 13 millimeters, okay, because I got the one with the 3 bars after that. So that makes it 1.3 centimeters. So that's going to be 1.3 centimeters. Okay, then I got to do the last thing. I need to figure out what's the height of this thing. So now I'm going to take the height and I'm going to bring it down here, and I have got 14 millimeters or 1.4 times 1.4 centimeters. Remember, I'm writing this upside down, okay, so that you guys can see this. So that's our block. Our block has a volume of 5.1 centimeters times 1.3 centimeters times, that's not a plus, that's a times, 1.4 centimeters. We can multiply that, and that gives us the volume of the block. Now, how in the world do we calculate the density of this? Well, that's going to be for another lab. Okay, it'll be another video that we'll talk about. So let's look at something else. What about something like this? This is a brass weight. This is a 200-gram weight, and I'm going to need to figure out the volume of this. Now, if you look on the side here, you notice, hey, you've got this handle here. For the purposes of our lab, we're not going to worry about the handle. We're just going to take this, and it's like a brass hockey puck. So what's involved in that? Well, the formula has to do, it involves radius. I don't have the formula off the top of my head, but it involves the radius. So what's the radius? Well, we can take this, and we're going to take our ruler here. Again, we're going to use our metric side, okay, as you can see, and we're going to go put it in, and I see, I'm going to take it at the widest point of my object here, and that's 4 centimeters. So that's 4 centimeters. That's the diameter. The radius is half. So our radius in this case, our hour, if you will, is going to equal 2.0 centimeters. So that's what we have, ladies and gentlemen. What about the height? Well, we can go ahead and do the height as well. We can go ahead and do that, and our height, it's about 1.7. 1.7, so there's our H, 1.7 centimeters. So let's go with a fresh piece of paper, and let's recap this again, okay, for how to read the metric system, okay, from here to here, that's 1 centimeter, okay, that's 1 centimeter, 1/100th of a meter, so we need 100 of those to equal a meter. Now, if we look down here, if we start looking, if we start looking at the individual bars, so if I started here to here, okay, and it's a little bit harder to spot, but it's right here, okay, between these two lines, all right, that, ladies and gentlemen, is 1 millimeter. So that's the difference between a millimeter and a centimeter. Okay, so that's how you read it, and I hope this will help you guys out a little bit on measurements. And, well, again, it's Cosmo Ye, signing off.